The important point in this class is you should understand the difference between the polynomial interpolation and spline interpolation. So for the polynomial interpolation, as you can see in the first graph, there are 3 data points are given. And for the polynomial interpolation, you are defining just one curve that can match to these 3 data points or to the given data points. So you are trying to reach these points with only one curve. So a unique nth order polynomial passes through endpoints. This is your aim for the polynomial interpolation, and it's not always easy to find that, but these are the most common choice for interpolants because they are easy to evaluate because this is just one polynomial, and it's easy to differentiate and integrate. So you can do easily calculations with the polynomial interpolation. Once we come to the spline interpolation, it's a little bit hard to calculate and evaluate, but it is much more confident choice. Because for the spline interpolation, as you can see, there are 5 data points, and for each data point, we are defining one curve for each of them. So instead of defining just one curve, between the first and second one, we are defining one curve, second and third one curve. So these are different curves we are defining in each data point. So that's the difference. Of course, these curves can be linear. So this will be linear interpolation. These curves can be quadratic or cubic. So you can use different choice, different degrees of polynomials between in each curve. So again, you are defining polynomials, but this time for each 2 data, you are defining one polynomial. And I showed you 2 different examples. For example, this is the blue curve is the exact function. And to be able to find the best fitting for this function, even though we tried 5th order polynomial, it doesn't fit well. And if we increase the order, this is the 19th order polynomial, as you can see, it doesn't fit well still. So increasing the degree of the polynomial is not the choice always. So in here you can see the linear interpolation. As I told you, it can be linear, quadratic, cubic, or nth order. It doesn't matter. This is the nth order polynomial equation, and if you get only 2 terms, you will have a linear interpolation. And for the linear interpolation, you need 2 data. You can take this data, the beginning of and the end of the data, or middle 2 you can take. It depends on the behavior of the data. You can decide that. And this is how we write the line equation, you know that. And this is b0 plus b1 x minus x0. Since you will have 2 points, you will just plug in and find what is b0 and what is b1. The aim in this one is trying to find these coefficients and write the function. Once you have the function, you know that the idea of interpolation, if you know x0 and x1, what is the value for x? That's why once you have this line, you can guess this value. And if you want to guess this value with the linear interpolation, this is how you can do it. This is one example for the linear interpolation. This is x points, and these are the log x function. So log 4 is this value, log 4.5, 5.5, log 6. Let's say you have these values and you want to know what is log 5, because there is the value of log 5 is not given to you. So we can do this with an interpolation, and let's do that with a linear interpolation. So let's choose the points 4 and 6 as the question tell us. And you know this was the function for the linear interpolation. And since x0 is the first point, x1 is the next point, x0 is 4, x1 is 6. These are the points we will be using that. And f of x0 here, as you can see, f of x0 is 0.6 blah blah, f of x1 is 0.7 blah blah. So what you need to do is just plug in f of x0 plus that one is f of 6 minus f of 4 over 6 minus 4, and you will get this value times 5 minus 4, because the x value we are trying to find is 5, and you can get this value. And since you can find the log 5 as an exact value, you can check how accurate is this as relative error. You can find the relative error in that way.